Alright, so drawing Lewis structures for ions is exactly the same except for one part, and that is determining the number of valence electrons. So when you see an ion, it'll be indicated by one of these charges here, and the charge will either be a negative or some sort of positive charge, either 1 or multiples. And what these will tell you is how to change your valence electrons. If you want to make a molecule have a negative charge, you have to add a negatively charged electron. So this tells you how many extra valence electrons you will get. So for NO3, to do the inventory of how many valence electrons we get, we do it as normal. So we have a nitrogen and 3 oxygens. So let's figure out how many each of those get. So nitrogen's going to have 5, and each oxygen gets 6. So we'll put those here, 6, 6, 6. And then we have to take into account this negative, which tells us that the negative charge is going to mean we get 1 extra valence electron. So we add all those up, 6, 12, 18, 19, 24. So there are going to be 24 valence electrons in this Lewis structure. Now if we go down here to, or let's do this one right here, SO4 2-. So I look up S, 1, 2, and there's 4 oxygens, so let's see how many valence electrons those have. There's going to be sulfur and oxygen. They all have 6. So 6, 6, 6, 6, 6. And then we have to take into account this 2-. And so because it's the 2-, that means there will be 2 extra valence electrons. And then we'd add these all up, 6, 12, 18, 24, 30, 32. So in this Lewis structure, I'm going to need to see 32 valence electrons. Down here for NH4+, we got a nitrogen and 4 hydrogens. And let's go find out how many those are. So nitrogen's going to have 5, and hydrogen each has 1. So nitrogen's got 5, 1, 1, 1, 1. And then this plus sign now is going to be the opposite. We're going to have to take away a valence electron. All right, so remember, negative signs mean you're adding valence electrons, and positives means you're taking them away. So we're going to have here a -1. So let's add this all up. 5, 6, 7, 8, 9. -1 is 8. So there needs to be 8 valence electrons in this final structure. So now let's go back and actually do it. So I'll draw NO3 here, and I need to see 24 valence electrons. So imagine I put a nitrogen, and then I'm going to surround it with oxygens. 1, 2, 3. And now I'm going to connect them with covalent bonds. And that gives me 6. And now I'll just fill in the rest to fulfill the octet rule. So oxygen, this oxygen on the top has 2, so it's going to need 6 more valence electrons surrounding it. So 1, 2, 3, 4, 5, 6. Let's go to this next oxygen over here. It needs 6 more around it as well. So I'll put in the lone pairs. 1, 2, 3, 4, 5, 6. Let's do this oxygen over here. Also, it only has 2, so it needs 6 more electrons. 1, 2, 3, 4, 5, 6. And then finally, let's do this nitrogen here. The nitrogen now currently has 6 electrons around it. 2, 4, 6. So it's going to need 2 more to satisfy the octet rule. So now I know the octet rule is satisfied for each element, right? This oxygen has 8, this oxygen has 8, this oxygen has 8, and this nitrogen has 8 surrounding it. And now I'll just count up the valence electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and 26. So now I know I have too many valence electrons, right? So I'm using 26 here, and I only get 24 over here. So what I have to do is I have to get rid of these valence electrons. So I have to figure out a way to move these structures around so that somehow I'm using less valence electrons. So when you find yourself in this position where you the octet rule is satisfied for everything, but you have too many valence electrons, what we're going to do is the same thing we did before is with our double and triple bonds, which is we're going to move electrons on the screen in order to try and eliminate some. So what we'll do here is let's take this lone pair And let's move them right here. So that way oxygen and nitrogen can share them both. So we'll create a double bond. Now, a reason I did that is because nitrogen still has 8 valence electrons around it, but what you'll see here is oxygen now has too many. Right? It now has 10 valence electrons surrounding it. It has these 2, 4, 6, 8, 10. So that means we can now get rid of some of these extra valence electrons right here that are around oxygen. Now we just removed valence electrons, which is our point, right? We needed to get rid of some, and moving that bond allowed us to do that. So let's count again now and see what's happening, how many valence electrons we've used. We now have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we've used all our valence electrons, and the octet rule is still satisfied. Oxygen has 8, this oxygen has 8, oxygen has 8, and this nitrogen has 8.